Hi everyone, welcome back. Let's take a look at problem 5. So problem 5 says that you have a parallelogram and the sides are of length 2 and 7 and one of the angles is 38 degrees. Well, we know this angle and this angle are equal and these two angles are equal in a parallelogram. So this is an acute angle and this is an obtuse angle. So this acute angle is the one that's 38 degrees. Okay, so we need to find the smaller diagonal and the longer diagonal. Well, if you think about it, if we started with a rectangle and then slid that top side over, that point that was here will come here, and so it's like sliding closer to angle C, and so this will be the shorter or the smaller diagonal. Whereas if we started with a rectangle and slid the top side over, this point here would be sliding away from point A. So this would be the longer diagonal. Does that make sense? I hope so. Okay, so let's go back to the smaller diagonal. So if we look at what we have, that diagonal splits the parallelogram into triangles. And so this triangle here, we have a side and an angle and a side. Side, angle, side, that's our law of cosines. And because of the way I labeled my points, this would be side A, the diagonal would be side A. And so we're going to use this form of the law of cosines. So I wrote that down, filled in the numbers, and I found that the shorter diagonal is the 5.5619 and so on units, whether it's inches or centimeters or feet or whatever. Okay, so let's go on to the longer one. We're pretty much going to do the same thing. The only exception is we don't know this angle. We know this one's 38 degrees. And so what we can do, because we know that the sum of all the angles in a quadrilateral are 180 degrees, and these two are equal and these two are equal, then we know these two have to add up to 180 degrees, and these two will be the same as these two, so these two add up to the other 180 degrees for a total of 360 degrees for the entire parallelogram. Okay, so if these two add up to 180 degrees and we know this one's 38, then we subtract and we find that this angle is 142 degrees. So now we have side, angle, side. We can use the law of cosines, and because of the way I labeled my points, this diagonal would be side B. So we would use this form of the law of cosines. And so plug in the numbers, and I found that the longer diagonal is 8.66396 and so on units, whatever the units are. Okay, so that takes care of problem 5. Number 6. Number 6 gives you a diagram, but there's not a triangle in the diagram yet. So you need to draw the radius of the circle somehow so you end up with a triangle. Well, that's no big deal. But then you have to think about what you know about tangent lines and a radius that goes from the center to that point of tangency. So that's my hint. Please do problem 6 and then come back and take a look at the next video. Good luck!